It's time for a new repair video, and in this video I'm looking at this. It is of course an HP9866A printer. This is a printer that sits on top of and attaches directly to the 9830A desktop calculator, and I need to get this working. I've had this for quite a long time now, and the reason I haven't got around to repairing this is because I needed the cable to connect it to the calculator. Unlike most other accessories for the calculator, this does plug directly into the calculator, but it uses a special lead that I didn't get with it. So as ever, I was looking for a means to connect this before I could really start the repair. I kind of given up the hope of finding one, and finally decided to make up a cable, and that's what I've done. So I've made up a connection cable, uses these weird round 19-pin connectors. So I've wired two of these together. They are quite expensive, which is why I was trying to avoid having to make this cable up. And then the next question was how to connect the pins together. Looking at the online images, it appeared that the cable could be plugged on either way round, so almost certainly the cables go directly straight through. So looking at the schematic for the calculator, that doesn't appear to be the case. We can see here this is the inbuilt interface for the printer. Very simple interface. It's just 7 data bits and a couple of flags, one each way. One's a ready flag from the printer and one's an acknowledge flag. So looking at the connections, they're lettered, so A upwards for the connectors, and that's what's shown on here. So we've got for example K, L, C and V for these top 4 pins. And then looking at the signal levels, if we look at the similar schematic for the printer itself, we see that exactly the same letters are assigned to the same signals. So this is just straight through. It's only about 10 cables or wires that are used, but I've actually connected all 19 on this just in case I want to use this for anything else. So now that I have this, I can actually start work and try and figure out what's wrong with this. As I say, I've had it for quite a long time. When I first got it, I gave it a really good clean and did some work on the cosmetics. Not a great deal, it was just mostly cleaning it and removing some stickers and a few scratches. There's still some scuff marks I need to get rid of, but before I go any further with the cosmetics of this, I want to see if it can be repaired and be brought back to life. Now, the electronics is not particularly complex, but the print head is pretty much irreplaceable. If that doesn't work, then it's the end of the line for this, and the chances of finding a replacement are pretty much zero. This is a thermal printer, if you're not familiar with it, and as ever, it is an ingenious piece of electronics in the way that it works. So as I say, it's a very simple interface. The host machine, the calculator, sends an entire row of characters, or up to an entire row, and there is no processor as such in this. It's just a state machine. There is a character generator ROM, but the incoming data is fed into 6 shift registers, and they're 80-bit shift registers, and it is of course an 80-column printer. There are 400 individual thermal print elements in this, so the head doesn't move, it's just it spans the entire width of the paper, and the heads are grouped together in groups of 5, so 5 for each character, and then they are energized as each line is required to generate the character as the paper moves through the print head. There are some complications in that because the print head uses quite high current, and for various other reasons of saving complexity, because there are so many print heads, it actually prints each line, that's each row of dots, in 4 groups. So it does a quarter of the row of dots in turn, moves on to the next row and does that for the entire characters. That's the entire, I think it's 7 rows per character. and then that's how it generates the characters on the paper. So of course it uses special thermal paper, although from what I gather you can just use fax paper, which is what I've got. So I picked up some standard thermal fax paper. This is 216 millimeters wide, which is what it seems to need. I think 210 is a popular size as well. That should also work. If you're interested, the connectors that are used for the cable, and it does fit, I have tried plugging it in and it does plug in. So that's the manufacturer's part number. So that's Amphenol number 2047 211 219 801. And if you buy them from Mauser, which is where I got these from, then the Mauser part number is 654-PT06E1419P. Okay, so they are quite expensive, but the cables are otherwise pretty much impossible to find, so that was the only option I had. Now I have tried plugging this in. I was asked what order and how do I go about repairing machines that I haven't started work on yet. And with this one, because I know it's been plugged in, incidentally when I move this I can hear something moving around inside, so I think it's something maybe broken. But what happens with this, if I power it up, it's drawing about 20 milliamps and not much current. It is set for the correct voltage. I've checked that. I've checked the input fuse and that's fine, but this doesn't do anything. I'm not going to plug it into the printer yet, the calculator yet, but what should happen even when it's not plugged into the calculator is this button should cause it to try and load up the paper. And what we'll do is we'll get the top cover off, start digging around, and the approach I'm going to take with this is to check the power supplies, and I'll then take out each of the boards and go through, check for shorts, all the obvious static testing that you've seen me do in the past on other machines. If I find anything, I'll obviously fix it, and then we'll plug it all back together, power it up and see if that gets us any further. So without any more delay, we'll get the top cover off and have a look inside. Okay, so that's the view inside. Very similar construction to the other HP98 series machines. We've got a huge transformer. It's obviously filthy in here, so it's going to need a really good clean. Huge capacitors, very big beefy supply on this, of course, to supply all the power to the print head. Huge stepper we've got here, and then just a series of boards all plugging into a motherboard at the bottom. As I said, I can hear something moving about inside, so if I tip this up, hopefully you can hear it. So I don't know if you heard that, but there's something rattling about. I think it's underneath the lower chassis. That's going to be a bit of a pain to get to, but I don't want to strip this down too far. I do want to clean all the dust and dirt out. There's a lot of dust in here, but what I'm going to do now is take out all the boards, and then we'll test the supply and see if the supplies are at least active and within the correct specification. If they are, we can start looking at the boards and working our way through, looking for any faults on them and putting them back. So what I'm going to do is start on this side. I'm actually going to leave these boards in to do the initial testing. They will help me determine if the power supply is working properly. So I'm going to pull these three boards on the left out. So these are the kind of the brains of the unit, and then we'll start looking at the supplies and seeing if we need to do any work with those. Okay, I've removed the two boards on the left. I was starting looking at the power supply board. This is the main regulator board, and there is a fault on this, or at least there was a fault on this. The supply is really split into two parts. There's a fairly high voltage, high power supply for the print head, and then we've got the supply for the control electronics, and it's that part that wasn't doing anything. There was no 5-volt rail. Now when I looked at this, there's some diodes, some steering diodes at the top here, and one of those was short circuit, and it looks like it's part of the crowbar protection system. So it was pulling the supply down. I'm surprised it didn't blow the input fuse, and I can assume it wasn't really doing what it was supposed to because the input current was very low, so there's something very strange going on. I haven't really looked into it in too much detail. What I did is I replaced the diode that was basically it had gone short, and I think it was just preventing the supply from coming up in the first place. So I've replaced that, and what I want to do now is power it back up and see if we get any more power draw. Hopefully you can see, just looking through the camera viewfinder, hopefully you can see the Variac display. We'll power this up. I'm referencing everything here to chassis ground, and we are now drawing about 1/4 of an amp from the mains, which is obviously far higher than it was and much more along the lines of what I expected. So if we now check the supply, we should have a number of rails on here. So we'll start, we should have 5 volts over here. This was 0 volts before. We are now getting 5 volts, and then we should have plus or minus 12 volts on this side. So that's plus 12 and minus 12. Okay, good. So that's working. We should have 12 volts down here, and we should have about 50 volts down here, which we do. So okay, well, it looks like the power supply is now up and running, so that could explain why it was completely dead. I'm also now getting a light on the front of the machine. Let's move the camera so you can see it. So hopefully you can see that the light is now illuminated on the front, which wasn't on before. So a bit strange. What I'm going to do before I go any further with this, because I don't know what the part is that's rattling about, and because it's sitting on top of the motherboard, which is obviously, if it's a nut or something, it could short something out at any time. So I want to get that out before I go any further, and I'm also going to give the chassis a really good clean. It is absolutely full of dirt and dust and all sorts of debris, so I'll give that a good clean, and then I'll move on to the 2 control boards and see if we can make any progress with those and if we can find any faults on them. Before going any further, I decided to take the cover off the motherboard. This entire bottom plate lifts off, and also remove the front cover. I'll explain why I'm removing these in a few minutes, but it's also partly to give me better access for cleaning. When I started taking the screws out, I noticed that the nuts that should be on the bolts at the top of this is now upside down of course, were missing, and I think that's probably what's inside here rattling about. So I don't think we're the first to look into this. Also, I started taking these screws out. I haven't touched this one yet, but I don't know if you can see it, it's halfway out. So I think somebody has been here before us, so I'm not quite sure what we're going to find in here. Let's take the other 2 screws out. Okay, well, not as bad as I was expecting. There's some dirt and dust in here, but not too bad at all. It's reasonably clean. Again, some strange, I've had this on the other HP machines that I worked on. I kind of get this strange sticky residue, and I am seeing what I think might be some poor solder joints. So yeah, we've got some loose wires on here, so that might well be what the problem is. I'm going to go and give this a nice clean now. I'm going to get the front panel off, give it a really good clean, and then I just need to investigate in this corner. I think we've got some loose wires. Yes, we've got at least 2 loose wires there. Okay, I've had a good look, and there are 2 broken wires on this connector, and also I think there's a couple of dry joints on this board, so I'll look at that as well. And what I'm looking for now is I heard something moving about in here somewhere, so here we go. So that's what was rattling about, and is indeed the nut that should have been holding the front cover on. So what we can now do is go and give this a good clean, and then start looking at working our way through the boards. And I will of course repair the 2 broken wires. While I've got it stripped down like this, I'll also disconnect and test the 2 capacitors, the 2 large capacitors, to make sure they're okay. The way I go about doing this is I disconnect one side, hook it up to a bench supply, and then I put an alternating load on it to give it a good thorough test, so it puts a very high ripple current on it. And I'll leave it run like that for an hour or so. I won't do that on camera, but if you want to see that sort of thing in future, let me know. And hopefully we won't find anything else in here broken. But as I say, I'll work my way through, look for anything that's not working the way it should. There's a nasty bow to this board that I'm a bit concerned about, so I might pop this board out and have a look on the other side, make sure there's nothing wedged in the gap. I don't want to take too much of this apart if I don't have to. I don't want to take the print head out unless I absolutely need to. I'm hoping that still works. They do tend to be fairly reliable as long as the electronics don't kill them, so that's why I'm usually fairly careful about the way I work on these. Okay, so I'll go and give this a clean, and we'll get back on camera and see which way we're going to go after that. Okay, so a quick before view. As I say, I have cleaned the accessible parts of this already, so I'll now take this over to the workshop. We'll get it cleaned out properly, and we can start putting it back together and working our way through the boards. That's the approach I'm taking with this particular unit. We'll go through the boards, do static testing on them. If I find any faults, I'll fix them, plug them all back in. We'll then power it up and see if we get any further. If we then start finding faults, then of course we'll investigate each board as we go. But normally on machines like this, because they're so discrete in nature, you can detect about 90% of the faults without powering them up, as long as you sort of work your way through them logically. But I want to get this cleaned. It is a bit dirty at the moment, and then we can start looking at the other parts. Okay, it's cleaned up really well. No real physical damage that I could find in here. It's cleaned up very nicely. I've removed all the debris. There was a lot of dirt in here, especially down behind the power supply. It was kind of fairly hard packed in there, and it's cleaned up nicely. A big heatsink at the front here, of course. The head needs to cool down as well as heat up. Otherwise, with prolonged printing, the head would gradually get hotter and hotter until we got to the point where you just had black paper coming out. But as I say, it's cleaned up nicely. Didn't find any real damage. I've been asked in the past why I go to so much trouble cleaning units I haven't yet got working. A couple of reasons. One is because I have every intention of getting units working, but the other thing is that when you clean things fairly thoroughly, you tend to find a lot of the faults that they have, whether it's missing screws or damaged components or things that are misaligned or bent. And I tend to find about 90% of existing faults during the cleaning process. Not only that, but when it's cleaned, it's far nicer to work on, and it leaves all the dirt and mess and muck outside the lab. I don't really want all this stuff falling out in here for me to breathe in for the next few years. So it's nice to get all the dirt out, and it makes the machine far nicer to work on. Okay, so I'll get this flipped over and we'll have a look underneath. I did find some faults underneath that I mentioned earlier. I'll have a quick look to show you what I've done, and then we'll start reassembling this unit. So looking at the underside, as you can see, I've cleaned this. There were definitely 2 broken wires on this connector, so I've resoldered those, touched up a couple of joints on this connector, which they definitely seemed to be fractured, so I've resoldered those. I checked all the rest on this board just in case, but they'll look fine. I did find a lot of debris underneath this board. I mentioned it was bowed up. It's just a lot of dirt and debris that had built up over the years underneath this, and it was holding it up, or down, depends how you look at it. So I took this out and cleaned that. Disconnected the large capacitor, did a proper test on that. Luckily I didn't have to disconnect this one. I could just pull this connector off, and the same with the connector on the underside, and then I could do a similar test on that, and they both test fine. And again, it's worth doing that if nothing else. It kind of brings them back to life before you apply power, and large capacitors like this that have been idle for years or decades can quite often blow a fuse or damage something if you just apply power directly to them. Okay, so I'm quite happy with what's under here at the moment. We might have to come back in if there's any faults that we find, but what I'll do now is refit the cover. I'll put the screws back in, I'll tighten them all this time, and then we can flip this over and start looking at the top side. So the next step is to just go through the boards and do some static checks. This is quite a useful way of working on machines like this, simply because if there are faults on these boards, then quite often you can get a kind of a cascade failure where other devices get taken out on other boards. So all I really do is, and this gets easier the more you do this, so when you kind of recognise components and you know their pinouts, what I tend to do is I find the two rails. Now on this board it's obviously extremely easy. You've got these big open gold plated areas that you can find. So if we find an IC and find its ground rail or ground pin, then we can determine that that is indeed the ground, and then we can do the same thing. There should be another one, which is probably this one, and what I then do is I just put one test probe on each rail in turn. So we'll start off with ground, and then I'll go through each of the devices and looking at their signals. Now it takes you a long time the first few times you do this if you have to look at the data sheet, but for example with the 7.4 we've got here, we're only really interested in the output pins, so on pin 6 and pin 8. I'm looking for anything that looks abnormal, and again you'll get to recognise the patterns for abnormal signals very quickly, and you can work your way through a board like this in probably 5 or 10 minutes just looking at various devices. And what you're doing is you're looking for anything that is kind of out of the ordinary. You're not going to know what the exact value should be because it depends on what other components, what other gates are connected to those pins. But if you work your way along, we're getting a 56k there, that's fine, that's not particularly unusual. And in fact if we measure across the two rails, if we go from ground up to positive, you can see that we're getting about 1.6k, which is fairly typical for a board like this. So don't worry if you do see some conductivity. So we work our way through the board, and I'm only looking here, as I say, at any pins that the devices should be able to control, and then I'll work my way through the entire board. If I find anything, then I'll stop and show you what I found. Okay, well it's about 10 minutes later, and we have a candidate here for a failure. So this is not a ground pin on this chip, and the other lead is on ground, but as you can see we are getting a very low resistance value, so that's not looking good. It's not necessarily this device, because obviously this goes somewhere else, so it might be another device. So all I'll do now is make a note of this, and I'll finish off the rest of the board. I've just got this row to finish. I tend to do it a row at a time, and then the bottom two rows to finish off. And what I'll do is find the other end, or where else this connection goes to. I should look on the schematic to do that. And what I then tend to do is use something like the Agilent 34461A bench multimeter, 6-digit or 6.5-digit meter, and in ohms range it will give me a very good resolution as to where the lowest resistance on the board is. And I'll tend to go from ground on each device that there seems to be a short on. So for example on this device it would be these two pins, and then I'll look for the lowest value on the board, and that tends to be where the failure is, and I'll pop that device out and then measure it again out of the board, and if that turns out to be the faulty device, then of course I'll replace it. So I'll get this finished off and then get back on camera and see if we find anything else. Okay, well, I've finished on this board. I didn't find any other shorts, just that one, and it turned out to be this device, so I have replaced that. And if we now try and do the same test again, notice we're now getting 70 meg. So that is now fine. I couldn't find any other faults on this board, so that one is now done, and I'll now move on, do exactly the same thing on this board. Incidentally, you can see I gave the board a clean before I started, and I'll do the same thing with this one. I'll give it a good clean before I start testing, and if I find anything wrong with this one, I'll again get back on camera, hoping I don't find anything wrong with the ROM. That's one of the few parts that would be extremely difficult to find a replacement for, so fingers crossed that works. Okay, I didn't find any faults on that board at all, so that one looks fine. Again, this is only static testing, so it doesn't guarantee that it works. And I'm just going to do a quick final check on the voltage regulator board, and then we'll get the machine back on the bench and plug these back in. I've got the machine back on the bench, and so we can start refitting the cards. So each one of the cards has got one of these guides. They've got an annoying habit of dropping out when you take the cards out, but it's probably better that they do that rather than snapping off. So all we need to do now is put the cards in. They will only go in one position because these connectors are offset on each one. So we'll just drop these in. So that's the first one. And then finally the regulator board. So as I said, I have checked the condition of the belt and that seems to be fine. Okay, now there is a securing bracket that holds these in place. In fact, there's two. There's one at the front as well. I'm going to leave these off for now until I've tried powering it up. And in fact, I'm going to power it up like this now. I just want to see if it will come back to life at all before I finish reassembling, and I'll do that with the front cover off. So I'm going to power it up and see if the paper drive works. It's not just an on-off switch for the motor, it actually drives some of the logic. So if the paper drive works, then we can be fairly confident that the machine is starting to come back to life. So I'll just get the mains connector plugged in. Okay, we'll get it powered up. Hopefully we won't see any of the magic smoke escaping. It's drawing about 0.4 amps, which is good. The top paper out light is now on, which is also good. That means that there is some logic activity, and again that wasn't on before. And if I try pressing this button, that's good. The motor's turning. That means that not only is the logic that's controlled, this basically generates some clock pulses into part of the control circuitry. That in turn generates the control signals required to drive the stepper. Also, we're seeing that the logic that detects the paper out is working, which I think is this micro switch here. Okay, so I can now fit the front cover. I mentioned that I took it off for several reasons. One was for access, so I could gain access to the various parts of the system. But the other reason was so I could clean this strip here. It's extremely dirty, and it's supposed to be, it's there so you can see what's being printed. So as you print, the part that's just been printed, or the line that's just been printed, is actually underneath this clear cover. But it's so dirty I couldn't read what was being printed. I didn't realise it was clear at first. And you can see, I just touch it with my finger, it's supposed to be transparent. So I'm going to clean that up. I'm going to polish it a bit with some plastic polish before I refit this. Okay, so as you can see, once it's been polished up, bit of nervous number 2, then it is completely transparent, and we can now hopefully read what the printer is trying to print before Previously we had to wait until the next line was printed, or we had to feed the paper out manually to see what the previous line was, but hopefully now we can see through the proper strip. So I'll get this refitted and we'll connect this to the calculator. Okay, that's the printer mostly reassembled. I'm going to leave the top cover off until I've tested it. Don't know if it works yet, of course. And so I've refitted the front cover. I actually thought this was broken when I first got it, because this corner sort of rattled about, but of course that's just because the nut was missing. But now it's nicely held in place. Looks much better. Now I can see through the clear part of the cover, and it's cleaned up quite nicely. The real question now, of course, is does it work? So I've been through this, can't find any other faults, so we need to do some dynamic testing now and see what happens once we connect it to a calculator. So get a calculator on the bench, we'll get this powered up and see what happens. Okay, I've got it connected to the calculator, and we'll try powering up the calculator, make sure it still comes back to life. I've got the signal cable plugged in, so hopefully it's not going to stop the calculator from starting up. And the calculator does appear to be running, so I'll now power up the printer. It's showing out a paper, and it does drive the paper roller. So okay, so I'll get some paper loaded and we'll try doing a print and see what happens. I'll just have to move the camera out of the way to do this. I can't reach far enough around to get the paper in with the camera in the way. So as soon as I've got the paper loaded up, we'll try and do a print, but I won't try and print until the camera's back on, so we'll see what it does together. Okay, so I've got the paper loaded up, and what we'll try and do now is see if it will actually print. So what I should be able to do is print directly to it. And fingers crossed, see what happens. And it does appear to be printing. So what I'm going to do now is load up a test program from our tape and see if we can print that off. Okay, so it's loaded the program. Let's rewind the tape. And what we should be able to do now is print that program directly to the printer. So, as you can hopefully see, it is printing very nicely. Nice clear text, no missing parts, at least in this part, at least kind of up to here as far as I can see. Okay, so that appears to be a successful repair. I'll get the top cover refitted, run it through a few more tests, but that seems to be a success. Not quite as interesting repairs as I'd hoped for, but that's the way they sometimes go. Just found a few faults, one failed IC, shorted diode, a few broken wires, that sort of thing, but other than that it was just in need of a good clean.